Okay, solving equations. So our homework quiz today, I'm gonna tell you right now, I'll have two questions. One of the questions is very similar to part B. And you will be allowed to use your homeworks. You will be allowed to use your notes. You will be allowed to use a graphic calculator. Just gotta work individually. That's all. But you could use this if you want. So if you need a guide, take a look at part B because it's gonna be very close to part B. Some more. On 26, but we've done these questions already anyway, though. Yeah. Yes, it's gonna be more like on 26. And I'll pull that up in a moment. But still, these are problems we have seen already anyway. So we want to make sure we're comfortable with that. Jazz, good? Oh, sure, of course. Is that better? All right. So for part A, yeah, that's pretty easy. I would subtract the 5 and divide by -3, and then just solve for x. That's not that hard. Subtract 2, multiply by 2, you get 4. And by the way, if you have a graphic calculator, you could always graph the equation to see where they intersect. You could do that. For part B, that's easy too. Well, yes and no. What you have to be careful about is that after you divide 5 and subtract 1, square both sides. If you square both sides, then you should solve for x. Now, one thing to keep in mind, you do need to check your work. The radicals sometimes may not always, might be deceiving. When you have radical equations, it might get 2 answers and one of them may not work. So you do have to check the answers by throwing it back into the original equation. Very important. Alexander, go ahead.
Take out 1 until you've already divided by 5.
Correct. Yes. Yes. Right. So you got to follow the right order of undoing it. Lois, go ahead. Yes, on the right side. Yeah. So I subtracted 12 and then divide by -1. And then after I change x, I don't know why I did that, but I did, I guess. Should multiply both sides by 3, but I made that 3x over 3, which is 5/3 x, and then divide by 5/3, so I should get 6. I don't know why I didn't multiply both sides by 3. That's what I usually do when I solve those, but anyway, that works. For D, divide by -3, then cube roots, and then subtract 1, divide 2. So these were all kind of review from a previous homework. In fact, actually, let me pull up the previous homework right here, which is probably that one. Yeah, that's when we start talking about rewriting, looking inside, undoing. So we talk about all this stuff. So yeah, this is totally from 2 homeworks ago, but the current homework brought back. So hopefully that's okay. And why can I not find my solution key? Oh, it's under here. Okay, let's keep going. Now, this is the newer stuff. You're not being quizzed on this today. Actually, I'm going to do another quiz on Friday, and it'll be on this stuff. So because you do have to know how to solve systems. Really simple, just substitute. Like for part A, just replace y with that expression and you're good, or set them equal to each other, right? For B, you have to be a little more deliberate about the substitution or more intentional about it. Replace y with x minus 2, square both sides, boom, 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 you're good. For C, again, substitute. Sorry, my handwriting is a little messy there. But really quickly, going back to A again, once you solve for x, plug back into the equation, you get y, because it is a pair of coordinates or a point where they touch. Because if you graphed it, there'd be a point of intersection, right, where they touch. That's the solution. For B, same thing. Once you get 2 answers for x, plug it back in to get each individual answer for y. And then, yeah, sorry about that. Y. Oh, there it is. Sorry. Geesh. Okay. That was ugly. So I set them equal, move everything to one side. You should get that. Pull out the 2, get 2 answers, 2 or -1. You plug in 2 for x or -1 for x, you get 45 and 3 respectively. Those are your pair of coordinates. And I will put this in Schoology. I have all the homeworks, by the way, for the entire unit, all taken care of, all the solutions. I'll put up in Schoology when I get a chance. I just got to go scan it. Charlotte, go ahead. On a quiz you would, or a test you would, yes. So for example, we don't see that yet. We'll see it in the next set of problems. But if you don't check and one of the answers actually did not work, that it was a 5-point problem, you'd lose a point. Because I'm giving a point for the answer. So you have to be careful about that. Jazz, good. Not for the quiz, no. But you can use graphic calculator. Okay, so for 8, 9, 10, these are all absolute value equations. The best way to handle these is take the expression inside the absolute value instead equal to the other side. But the other side also has to be its negative counterpart too. So it's not just 14, it also equals negative 14. So you gotta look at both. And when you check, both do work out, so they're fine. But you have an issue for 9. F plus 3 equals the other side, but also F plus 3 equals the negative of the other side, which is negative 2F minus 4, because it equals negative counterpart. The problem is that you get negative 7/3 for the second solution. It does not work when you throw it back in and check it. The right side does not equal left side, so you have to cancel that out. And by the way, that's just page 17. That's not an answer, just that's a little crazy. And then for 10 minus 7g equals 2g, or 10 minus 7g equals negative 2g. Solve each one, and actually both work out. Both are fine. Graphically speaking, why does one fail? One fails because the absolute value looks like this. Like if I were to kind of sketch it, it would be that. And then the equation, who knows how the equation looks? Actually, I do know. It's kind of like, I don't know. I'm trying to think how this is being said. I think the equation kind of looks like this. It's only touched once. But sometimes it can be like this. They could touch twice. Or they can miss each other. That could happen too. So algebraic, you have to be mindful that some of the answers may not be valid. You have to go back and check by putting back in the original equation. Very important. That's what this means. Check for extraneous solutions. I will specifically use that phrase on the quiz. Check for extraneous solutions. Just means check your answer, make sure it works, and you throw it back in. That's all it means. But the one I'm giving you on the quiz today is going to be a square root function, just so you know. And remember, when you have solve square root functions, you have to square both sides. Once you have the radical isolated. And also, be very careful here. Please, please, please. I'm giving you a heads up. When you square both sides, after the radical is
By itself.
thank you. Not right now. It's +1. Because if you square both sides, you have to FOIL this with +1. And that makes it nasty. Move that one over, then square both sides. Okay. So I'm kind of feeding you the solution right now, but we'll do the quiz in a little bit. The word problems are a little tricky. So we'll talk more about word problems today as well as Friday. Just make an equation. So you don't know the number called x. I don't know what it is. Great. So when 14 is taken away from that, it equals 5 times x. There we go. Square x, subtract 14, equal to 5x. Move everything to one side, factor it, and you get 2 answers. And that's how you solve it. And it makes sense, right? Because what happens if I take what happens if I square 7 and then take away 14? What do I get? 35. What's 7 times 5? 35, right? Or let's look at -2. If I square it, I get 4. And what's 4 minus 14? -10. What's 5 times -2? -10. There you go. 12 helps a draw. You have 2 dimensions, width and length. Width is 1 less than the length. Great. What's area? You guys should know this by now. Area is length times width. Replace the width with the new expression L minus 1. You have another quadratic. Solve it. You get 2 answers. Of course, the length can't be negative. That's impossible. So go with the positive value. That means the width is 7, and it all makes sense. Does that make sense? So I did 12. And finally for 13, that one's a little funny. You have 2 parabolas. You graph them and then just see where they touch. That's really all. And I don't know what I was doing over here. I was trying to do algebraically. That was really dumb because the answer's too nasty and I don't want to deal with that. Just do it graphically and that would make the most sense. Yeah, Lincoln, go ahead.
You have to turn y equals.
Mhm. Mhm. Well, I mean standard form, like distributes. No, you don't have to. It's not necessary. I actually liked it the way it was because it was easy for me to identify the x-intercepts and then the vertex afterwards. So I actually graphed it without using a calculator. The other one I was able to graph as well without a calculator. What I could not do without a calculator is see where they touch. That was not obvious. I knew it was between 4 and 8, but I wasn't really sure 100%. So that's where you have to use a calculator to do that. Charlotte, go ahead. Yeah, go ahead. Yeah, please. You'd be fine. Yeah, exactly. Yeah, if you had like maybe x and x minus, well, I don't know how you would do it, but that's fine. Yeah. That's all good. Yeah, not a problem. But yeah, and so these are all just word problems that involve quadratic functions, right? This is what this unit's been about. So okay, hopefully we're all good with that. Okay, so why don't you guys turn the page? Let's go to page 19. We're now going to move on to solving inequalities. We're going to do 19 and 20 today. Then afterwards, you could work on homework, which is page 21. It's just all page 21. That's it. Homework's, I don't want to say it's short because each question has 3 or 4 parts. So this could take a while, but after I finish the lesson, you can start the quiz. Yeah. So once I finish today's lesson, you guys can start the quiz and take as much as you need to do the quiz. Oh, the other thing about the quiz here, I forgot to say. There's gonna be one word problem as well. The word problem is gonna be just like the previous one, like the steamboat one, where you had to make like a parabola. You had to write the equation of parabola from this, from the diagram here. Or this garden hose one. It's kind of similar kind of problem. So I actually will give you a diagram and I'll give you the dimensions and you have to write the equation. Do you guys remember how to write the equation for this? How did I, we'll talk about this right now just so you guys remember. How did I do this? Do you guys remember? You do something like this, or you could do it like this here, like where the person is. Um, actually, let me take it back. So you guys see what I'm drawing here? What am I drawing? Parabola, great, awesome. And I'll give you the standard form or the standard form for a parabola. If you guys know it, that's great. But if you don't, no worries. I'll give it to you on the quiz. So if you do that, what's my vertex? What's H? What's K? What do you guys think? Yeah, great, perfect. Thank you, always. 5 and 8, awesome. Now, if you think about these points here, this is a little tricky, but they say that a person release the water leaves the hose when the hose is how far off the ground? How many feet off the ground? 4, right? So what I could do is make my equation y equals a x minus 5 squared plus 8. I got to plug in 10 for x and 4 for y. A. Let me get rid of this stuff here. Yeah, solve for a, and you'll get your answer afterwards. So you're going to see something kind of like that on the quiz. That should be 25a plus 8. Solve for a should get -4 out of 25. So the equation would be y equals -4 out of 25, x minus 5 squared plus 10. So that's the other question on the quiz as well. Again, I'll give you a diagram. I'll even instruct you of how to put the coordinate plane onto the diagram. You really should actually, if you put the if you put this part, the vertex on the y-axis, that's fine. The equation will still be valid. But I'll specifically say, hey, put the y-axis, put the origin. Like, where's the origin here? It's at the woman's feet, right? Or the yeah, it's one. So the woman's feet. So yeah, so you put the origin there. So the rest should all make sense. So this is modeling. That's what we're trying to quiz you guys on. Questions on how that one's done? Does that make sense? How I went about it? So again, put the coordinate plane on the diagram, label, get the vertex, plug it in, but then you got to solve for a by using another point on the curve for x and y, solve for a, and you have the equation. So these are just like some key skills. I want to make sure you guys are comfortable because that's what we've been doing, this stuff and solving equations. So, all right, we're good? Cool. All right, now let's do the lesson. All right, here we go. So on page 19. All right. So this is highly mechanical stuff. There's really not much word problems, I guess. Just really just algebraic stuff. So if you're asked to graph an inequality, like let's look at you guys may have done this before in algebra. I don't know. We'll just start with this one here. How would you graph that? What would you do? What would be my first step? What do you guys think? What was that? Sorry. Wait, how should I handle part 1 here? Yeah, go, Jasmine. Well, not quite. Right now, what do I have on the left side? Do I have y or 2y? What should I do about that 2? Move it. Yeah, let's move it over. So it should look like this now. Half x. Okay. I probably won't do all these because I think it's gonna get really redundant, but so what form is this called when y is by itself? Do you guys remember what that's called? It's linear, but also it's called slope-intercept form. So if I have 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Okay, what's my y-intercept here? Perfect. Good. What's my slope? So you go up 1 and right 2.
What's the one?
-3/2 or -1.5. And I go up 1 over 2. And then what do I do about those two dots? Just connect them, right? So you guys have done this many times. This is nothing new. The only thing that's kind of new or just different, the inequality part, right? You guys remember what to do when you see an inequality? What you have to do after you graph the lines? Jazz, remember? Oh, okay, great observation. You do a dashed line if it's just greater than. Because greater than or equal to, you have to keep it solid. How do I shade? Up or down? Well, y is greater, right? So guys, if you think of greater, do you think above or below when you see greater? So go above. That's it. That's all you do. Here's another thing you could do as well. Look at 0, 0. Is 0, 0 my shaded region? It is. Does it work in the original inequality? It does. If I plug in 0 for x and 0 for y, does that hold true? You bet. 0 is definitely larger than -3. So I know this works. Now, if 0, 0 is not part of my shaded region, then it should fail. If it fails, that's okay. So it just depends what you got. Does that make sense how I handle that one? Okay. So let's try let's do 2. I won't do 3 and 4 because I think you'll get the point after I do number 2. We'll just do one more of these. We don't have to do 3 and 4. We can cross those off. We'll just do number 2. All right. Now is y by itself. Get it by itself. How do I get it by itself? Well, sorry, what's the first thing? Subtract the x first. I would do that. I like the flip part. I like what you said there, but let's hold off on that for a moment. Let's do the x first. Okay. Now what's my next step? Divide by -2, but you have to flip. Let me put this in red so it stands out. This is so important. A lot of people mess this up because they're just not careful.
Why did the flip?
Great question. I'll explain in a moment. But when we divide by a negative, you must flip. When dividing an inequality by a negative number, we must change the direction of the inequality. Yes, we must do that. Okay, let me explain why. Or does someone know why? Out of curiosity? Yeah, Ellis, you know why? Well, let me expand on that because you're on the right track. What if I moved the -2y from the left side to the right side? Then what's going to happen when I isolate y? So if I move this, notice I kept it on the left side initially, but what if I move it to the right side? Now is y going to be less than or greater than? Yes, exactly. That's it. That's the reason why. See, you want to guarantee. No, definitely, you're right. Like when we multiply by negative, all the signs change. But the true reason why we have to flip, we have to guarantee the same results. If I decide to move y to the other side, what if the y jumped to the right side? So now what happens? Let me change colors so it stands out. So now what happens? X is greater than or equal to 2y minus 7. Then x plus 7 is greater than or equal to 2y. So y is less than or equal to all the other junk. That's why we have to flip it. You have to guarantee the same result if you took a different pathway. It's like if you want to get up to San Francisco from here, take 1 over 280, you still end in the same place. You take two different pathways, but you still have the same destination. And we have to guarantee that. That's the reason why. It's not just some rule. There's actually a rhyme and reason. So now you have this. Okay, great. You saw this. We flip it. Now we just graph it, and that should be easy. What's the y-intercept here? Which is, what was a decimal? 3.5. Yes, 3.5. And your slope is up 1/2. Connect it. And now you can shade it above or below. Why below? Exactly. And also 0, 0 is in the region, and it does work. If you plug in 0 for x and 0 for y, it does work. So we want 0, 0 to be part of our solution. So that's another way we could check as well. But less than means below, because y is a vertical coordinate. Remember, when you have y isolated, then you can do this whole up down thing, right? Because, oh, cool, it's above, greater, less, right? Or below. So it's all intuitive, hopefully. Okay, and one other thing that I know Jasmine mentioned this earlier, if I didn't have that equal sign, then how would I draw that line instead? You got to do dotted, yes. So be mindful of that as well. Because then it can't be on the boundary. So, all right. So let's take a look at 463. Okay, questions so far on 72? Nope. All right. Okay, take a look at 63. Okay, for each of the following graphs or system, note the equations. Okay. Hold on. Find the equation in the quadratic system that could have the solution shown. Actually, I don't know what they want us to do. I'm a little confused. I think it's just to state the solutions. I think that's what they want. Yeah. Well, let me work out part A. It seems a little strange to me. So this is actually a system of equations, not inequalities. And so here we actually have points of intersection as a solution. Like, I think I know what they're trying to get at. They're trying to illustrate the difference between a system of equations and a system of inequalities. But A is a system of equations. Where do they touch, guys? What do you guys think? X equals what and X equals what?
3, -3 and 4.
Actually, the first one's kind of tricky. I don't think it's terribly obvious.
1.5.
Yeah, I'd probably say X equals -1.5 or X equals 4. Definitely 4 for sure. Yeah, 4 comma 0. The other one doesn't seem very obvious to me, but I'll just say that. But that's okay. We're just trying to illustrate the difference between that and the inequality. So here on the right side, that's what we call a system of inequalities instead. So the way you're going to write it is you're going to say y is less than or equal. And here, you're going to say greater than or equal, just greater than. Because in this case, that's going to be 2y is greater than -x plus 4, or y is greater than -half x plus 2. So it's going to be rewritten like this. Y is greater than -half x plus 2, or y is less than or equal to -1/3 x plus 3 x minus 4.
How do you know that this one's an equality just because it's shaded with dotted?
Exactly correct. Yes. Oh, and actually, you know what? The parabola was dashed too. My apologies. The parabola was dashed. They're both dashed. I didn't see that. And so in this case, the solution is the shaded region. So how many points are in my solution?
2.
Actually, it's infinite. There are infinite possibilities. So there are, let me erase this to the other side here. Now you got the point for the left side. So for the right side, a shaded region represents an infinite set of points that satisfy both inequalities. That is precisely what's happening. Okay, that is the whole essence of this topic. All right. So you have the shaded region here, great. Infinite points that fit here. That's what's happening. So you represent the answer with a shaded region. Okay, we're good. All right, so let's actually solve this for 462. And then we'll do 493 and we're done. So we're almost done here. Okay, 462. This is going to be solid, just so you know. A solid curve and shade above. And we'll do four screen for this one. This will be a dash curve and shade below.
How do you know it's shaded below?
Just less than. Yeah, that should be intuitive. So let's just go straight to part B, and I'll answer part A afterwards. But let's go straight to part B. The show the solution means a graph. Graph and shade. So let's do it. I should use Desmos, but that's okay. I'm gonna do this by hand. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct, yes. Okay. Let's do the green. Can I factor that? How do I factor that, guys? 3 and 1. Yep, 3 and 1. Perfect. Yeah, Nathan, go ahead. Yes, 100%. 100%. It's just an expression. So -3, -1, and then where's my vertex? -2, comma what? What do you guys think? If I plug -2 back in, what do I get? What? Good, you get -1. Yes, good. And we're gonna have to dash it, by the way. Okay, that is very sloppy, but just go with it. Okay, that has to get dashed. Let me get rid of this little arrow thing here. So hopefully that's good. Okay, cool. Now, this one. Let's go pink for that one there. Y is greater than or equal to, okay. I'm just gonna kind of just sort of do it by trial and error. 2x and x. I want to take a stab as how that's gonna factor. Not many options. You have -3. What do you think would make sense? How would you break it up? You have to multiply -3. Yeah, if you do that, that should work. So you have an x-intercept at -3 still. And another one at 1/2. And I'm gonna get a little lazy here. I know my y-intercept is -3. Yeah, it's kind of yeah, just by plugging back in the equation. And it's kind of a steep. I'm just gonna kind of I'm just gonna get really lazy, guys. My apologies. Um so I got a shade above that. but below the green. So how do you think that's gonna look?
So just in that part there.
It's gonna be in between, yeah. That's my solution set. Because you're going above the pink and below the green. So you're just looking at those boundaries. So when they say does -3 comma 0 make both inequalities true? No. Doesn't make the second one true because there's a not equal sign. -1 comma 1. I don't think so. I'd say no for that one as well. You plug back into the inequality. I don't think it works.
Either of them.
Hold on a sec. Yeah, it won't work. Yeah, so that's no also. 1 comma 5 I think does work.
You can just plug it into either of them.
Right, exactly. Yeah, that'll be a yes. But I think the shade region should show you that too. So 1 comma 5 is in the shade region. I know I didn't make it very obvious. Probably should use Desmos to be honest with you guys, but those are not. So that's what's meant by a solution. Does it make both inequalities happy? 1 comma 5 does. The other two do not. -3 0 does not. -1 comma 1 does not. Okay, last one, and then we'll do the quiz. Okay, I'm gonna get smart about this. Let's just go to Desmos. I just realized that's probably best option for us here. You guys can just sort of do a quick sketch. So y. And by the way, if this were like an SAT style question, I would totally use Desmos, just so you know. Would not hesitate. To pull up the inequality stuff.
Like graphing calculator, how do you graph actual value?
I'll show you guys on Friday because I don't have time to do that today, but I can talk about it on Friday. So if you pull up this little keyboard thing, type abs, or they have a symbol for it too. That's X. Ooh, look at that. That's nice. Yeah, it does it so much better. And then here Y is less than or equal to negative abs X plus 5. Thanks, John. All right, cool. Lovely. What did I so what am I looking at here? What's gonna be my answer? The combined shaded region, yes. So this right here is my solution set. It's basically the overlapping shaded region. Okay, the overlapping shaded region. So you're going below one curve, above the other curves where they meet up. We're cool with that? We're good? All right. So that's what part A is asking us to do, right? Is that right? Part A is asking us, oh, what polygon does intersection form? Yeah, what would you call that? I mean, it's obviously a quadrilateral. Is it a square? I don't know. Actually, it is a square. I think so. I don't know. Maybe. I would just say, at the very least, a quadrilateral or rectangle. I think just being on the safe side, I'll call it quadrilateral. The vertices are pretty easy. Vertices are super easy. Just locate it, right? Not that hard. Yep. Actually, I think that is a square. Yeah, that's a square. If you were to find the distance for each side, it would be equal. That's a square. To justify, you need right angles. This is not a geometry class. We won't worry about it. We need right angles and also, yeah, our same length. Vertices were 0,4. No, 0,5. Yikes. 0,5. 4 comma 1. I think 0 comma -3. And -4 comma 1. And find the area of the intersection. Okay. Do you guys know how to find distance between 2 points? You guys remember? You can do that or the easier way. You count it. Yeah, if you do this, I like that better. Totally 100% think Aiden. Yeah, 3, 4, 5. What's the area? 25, yeah. Yeah, that's a great geometry problem. Not quite what we do in this class, but yeah, there we go. So cool. All right, perfect timing. Yeah, the other note. So you guys have learned how to graph inequalities, shading, dash, whatever, all that stuff makes sense. Homework will be this stuff here. The answers I have already produced, I'll put that in Schoology later today. This homework will do Friday. Again, while you guys are working on a quiz, I'll come around and give you your grade printout, and I'll put the actual percentage of what your grades in the class right now. Any homeworks you're missing, try to get them in before Thanksgiving break, so I can at least have grades updated, and that way you don't have to do any work over Thanksgiving. I don't want to do any work during Thanksgiving. Want you guys enjoy. Of course, if you want to do some studying for the final, for the test, you can. But I'm not gonna sign any. Just I'm not signing any homework over break. But it's up to you if you want to start reviewing for the test, or if you're just like, look, I need to check out. I need a week just to not do any math, or you've got like CCS. Hopefully, you guys win, have another game during Thanksgiving break. Cool. That's fine. Hopefully, we'll play in the CCS championship. It's up to you, Nathan. You got to make those field goals, right? All right. So anyway, no pressure. Yeah, there we go. Anyhow, but when we come back, we'll have plenty of time to review as well, just but yeah, but try to get stuff done during before break. Like if you're missing any assignments, that might be a good idea. Yeah. No, it's just gonna be page 21. That's it.